What's up? What's up? It's your man Jimmy Chan. So today we're talking about parabolas. So with a parabola, this is a little bit different way of how we usually looked at it. In this case, you have quite a few different things going on here, right? Here, we call this the vertex, and you usually call that part of the parabola the vertex, right? So V is your vertex. Okay, you guys already knew that part, okay? Now the F that you see here, that's called your focus. Okay? Now, this line right here is called your axis of symmetry. That is in dotted line. Okay? Draw it straight here. Let's make it a little bit thicker. And let's make it dotted. Okay, so that is your axis of symmetry. Actually, you know what? Let's do this a little bit longer. Okay. So the way the parabola is that here you also have some called the directrix. The directrix is equidistant from the focus. So the distance from the directrix to the vertex and the vertex to the focus is exactly the same. It's a distance of A. So the distance from directrix to the focus is 2A. All right, so here's the other part. If I drew this line that goes through the focus, parallel with the directrix, okay, parallel with the directrix, through the focus, all right, you can see that this is made connecting 2 points right here and right here. And again, this is a line that goes through the focus. Let's keep it solid. All right, so is again going through the focus and hitting the two sides, and it's parallel with the directrix, okay? This distance here from the focus to one of these points is also A. The other side, also A. So the full length would be 2A, okay? So if you look at this pink line is called the latus rectum. Okay, and that latus rectum is parallel with the directrix and is 2A away from the directrix. The width of the latus rectum is also 2A. Okay, so the focus to one side of the latus rectum is A, and focus to the other side is also A. So these are all essentially points that you're going to be given here as you're reading through things. Okay, so when you look at this, what we're going to have is it all depends on which way it's facing, right? If we have y squared is equal to 4ax, since the y squared, the y value is squared, that means it's either going to open left or right. And if the x is squared, for a y, then this is either going to open up or down. And it all depends on, you're wondering what, it all depends on, I'm trying to think of a better way of doing this. If the A is positive or not. Ooh, that's very crooked. So if the y is squared, that means it opens left or right. So if the A is negative, it opens left. If the A is positive, it opens to the right. For the x squared, if the A is negative, it opens down. And if A is positive, it opens up. So you guys are more used to things like this right here, okay? And if you think about the quadratic function, I usually have an x squared, right? So what you're used to is the up and down, and that's what you're used to here. You're not usually used to seeing y squared, but the y squared just turns it to the side instead. So that's all these tables are saying to you. You're welcome to use these tables if you want to. But it's not really necessary, right? It might confuse you. It might seem like there's more information to give you rather than just kind of getting through it. So essentially, if this part makes sense, then you're good to go. You're good to kind of skip this part of it. I think this picture right here is kind of important because of the different distances as you're kind of drawing these problems out. And when we get to the problems, you'll understand exactly why. And I'll try to refer back to it. Now, notice how that, let's say, for example, right here, right? This is y squared minus 4ax. If there is nothing subtracting from the y or something subtracting from the x, we know that this center is at 0, 0, right? So this center is at 0, 0, okay? Or the vertex, I'm sorry, vertex, right? So once, however, if you get like y minus 2 squared is equal to negative 4a times x plus 5, then you know that the vertex has changed. In this case, the vertex would be negative 5 comma 2. Okay, so everything inside the parentheses is subtracting. So again, if you don't see anything like with parentheses where you're subtracting something or adding something to the y or to the x, then you know that it defaults to the vertex of 0, 0. Okay, so I didn't want you guys to think that there is more into it because, you know, again, they give you this table over here talking about this. And the main part that you have to look at is realize, again, this is still telling me it's y squared with a positive a y squared with a negative a, turning left, turning right, x squared, positive a, it opens up, x squared, negative a, it opens down, okay? So those are key things that you have to look at. So let's go ahead and jump into a problem. It says find the equation of the parabola described. Find the 2 points that define the lattice rectum. The graph, the equation. Vertex is at 0, 0. Axis of symmetry is the y-axis containing the point 5, 3. So here is what I would do. Let's throw a piece of graph paper down here. It says to me that the vertex is at 0, 0. So I'm going to go ahead and underline vertex in red. Actually, let's highlight it in red. Vertex 0, 0. And now I'm going to use the red marker and go vertex. Okay. Axis of symmetry, let's use purple. So let's highlight this in purple. Axis of symmetry is a y-axis. So let's draw this purple line here that goes down the y-axis, and let's go ahead and make this line dotted. There we go. All right, so that's the axis of symmetry, and then the point 5, 3, 2, 4, 5, 3. So here's the point 5, 3. All right, so from here, this is the point where I kind of have to look at this and going, okay, so I have to know that this does not point left nor right because the axis of symmetry is here, which goes through the vertex, right? So it has to open up or down. But this point right here tells me it has to open up. So I have to have something like this, okay? So I know that it's going to be something like this. Great. So since it opens up, that means I have the equation x squared is equal to 4ay, right? Number one, it opens up, so my a is positive. I know it's going to be an x squared, and since my vertex is at 0, 0, that means I have nothing subtracting or adding to x and y, all right? So, bingo, there we go. Great. Now, I have a point here, 5, 3, and let's go ahead and highlight 5, 3. I guess with that being said, I'm going to have to change that to blue, right? So let's put this point into it, because I can't assume that this is part of the latus rectum. I can only know these two things right now are solid, and this is, with these three things, it tells me that opens upward. So I get the formula. Great. I can't assume anything else. I don't know what A is, what 2A is, or anything like that. So only thing I can do is take this point and plug it in here. So let's plug it in. My x value is 5, my y value is 3. So I'm going to have a 5 squared is equal to 4a times y, which is 3. So I'm going to have a 25 is equal to 12a. So my a is going to equal to 25 over 12, which is approximately, let's see, 25 divided by 12, it's about 2.1-ish, okay? So that's my A, okay? So if I know that this is gonna open like this, right, then I know from the focus, from the vertex to the focus is gonna be a distance, right? So let's go ahead and use that. So the focus is going to be 2.1 away. So the focus is going to be something like this. We'll call it F. And the directrix, we're going to run out of color. The directrix is also 2.1 away from it. So it's going to be about right here. So here's my directrix. And this directrix is an equation of a line, which is a y value is equal to negative 25 over 21, which is that 2.1 thing-ish, right? Great. Now, because I have this distance, I have that a is equal to 25 over 12. That means 2a must equal to 25 over 6, because I got to multiply this by 2. If I multiply this by 2, this can reduce down to 6, so that's why it's 25 over 6. And if you don't believe me, feel free to multiply this fraction by 2, and you're going to get like a 4.2 something, right? 4.2-ish, or 4.1 something that's going to round to a 4.2, all right? So if 2a is 25/6, then I can go, let me see here, purple is used. Wow, so many colors being used at the same time. I guess I only have brown for the latus rectum. All right, so 25 over 6, 25 divided by 6 is about 4.2-ish. So we'll just say it's approximately 4.2-ish. So that means I have to move 4.2 from the focus to the right and to the left. So 4.2-ish and 4.2-ish. So this line right here would be my latus rectum. I should connect the 2 points, okay? The question is, what are those 2 points, right? So the latus rectum from 0 to here, right, is this, and the y that went up is this right here. So my point for the latus rectum is going to be my x value is plus or minus my 25 over 6, comma, my y value is going to be the 25 over 12. So there's my 2 points for the lattice rectum, okay? It's asking for me to graph this equation. So I got the lattice rectum, perfect. So this graph is gonna look something, gonna look something like this. Let me see. There we go. All right. So again, the information is all given to you. You just got to figure out how to find my A and my 2A so that I can start graphing. And notice that, whoa, what happened here? Something went wrong right here. Oh. This right here should be right there. So let me do this. That doesn't look right because that doesn't look like it's equidistance to it. That's where the directrix should be, which is around that negative 2.1-ish, right? All right, so there it is. So let's go to the next example. All right, this one says, find the equation of the parabola described below. Find the 2 points that define the lattice rectum and graph. All right, so same thing. Let's go ahead and throw a graph paper here. And this says that my vertex is at 1, 5. And my focus, so let me do the vertex, highlight this in red. Draw the vertex in red. 1, negative 5. 1, negative 5 is right here. That's my vertex. And then let's take the blue, highlight this. The focus is 1, negative 6. So 1, negative 6 is right here, and this is the focus. So automatically, I know that wherever my parabola is, right, my vertex is here, my focus has to be within, okay? It's like two arms hugging on the focus, all right? So that's what I gotta pretty much focus on. So in this case, if the focus is below the vertex, that means I have to do something like this, right? I have to actually face downward. And since my vertex is off, that means it's not a 0, 0. So therefore, my equation is going to be different. But since it goes up and down, I know that the equation has to be x squared, well, x minus h squared is equal to negative 4a times y minus k squared, right? So because I know it goes up and down, I know it's going to be the x, there's no y squared. I know that the x is going to be squared and the y is not going to be squared. And I know it faces down, so that means my a is negative, okay? So with that being said, I can see this. So if my vertex is here and it's 1 unit away from the focus, that means my directrix is going to be right here, which my directrix right, that directrix is going to be what y equals negative 4, just for the reason of where the vertex and stuff is. So the other thing is that remember how we talked about these distances here, right? These distances here is my a value, right? So that means my lattice rectum is going to be a value each direction as well. So my lattice rectum, lattice rectum is going to be one this way and one this way. So my lattice rectum is going to be this right here. So in that case, my lattice rectum is going to be what? 0, -6, and 2, -6. Just like my focus, the y value stays just like my focus, all right? So I already know that this is going to open down. I found my lattice rectum, right? Now I need to find the equation, right? So I know, so how about if I do it this way? So I know that this distance right here has to be a, which is equal to 1. So that means I can use that right here. So my vertex is at 1, -5. So I can say, great, I have x minus my 1 squared is equal to -4 times a, which is equal to 1. I guess I should use this something as different, because now you're gonna think that one of them is gonna be the same as the other. So let's go ahead and use, I haven't used purple yet, so let's use the purple. Okay, so you know that the purple is coming from down here, so I'll put the purple as 1, and then the y minus a -5. So I have x minus 1 squared is equal to -4 times y plus 5. And there's my equation right there. Define lattice rectum. Awesome. So my lattice rectum is right here. There we go. All right. And then if I was to graph this, there we go. And there's my graph. All right. All right. So I'm going to skip a couple of these because I want to get to something like this, right? So most of the problems, if you just kind of trace it out, you'll start to see it. But again, I would tell you to take this, like for example, when I drew this, I already had in my head that I'm seeing where the A's and the 2 A's are to help me out, okay? So that's what is helping me there. So the issue is that when you get to a problem like this, it becomes a slightly different issue, right? So here I see that the x squared is not by itself. I have a 2x here, and the y is not by itself either, or a product of something. So I know that this has to be an x minus h squared is equal to 4a times y minus k. Okay, I know that's what it's got to be. So what I see on the left side, the x squared minus 2x, is that this needs a completing the square to get it looking more like that, okay? And then equals the right side of -y plus 1, I'm going to have to do a GCF so that it kind of looks like the right side here. So I'm going to have to, in this case, I'm going to have to do a GCF so that it looks something like this, Okay, great. So let's go ahead and deal with this. So completing the squares, I remember that I have, let me see here, new c, right? I gotta find a new c. That's b divided by 2 squared, which is equal to -2 divided by 2 squared. Now, I always tell my students to do the work. So -2 divided by 2 is -1 squared, which is equal to 1. So I got to add 1 on this side. That means I have to add 1 on the right side. Great. So now I got to factor this left side. When I factor this left side, I'm going to have a x minus 1 squared. Over on the right side, I'm going to pull a GCF of -1 out. So -1, and I'm going to have left a y minus 2, right? Because 1 plus 1 is 2. And then if I is positive 2, and then if I pull out a -1, it becomes a -2. Great. So here is what I have here, right? So automatically I have my vertex. I can see my vertex, and that's going to be a 1, 2. So I got my vertex down. It has the other things asking for it too, right? The focus and the directrix, right? So since I could notice that this is going to be an x squared, I know it's going to be open up or down. But let's take a look at what the A is going to be, right? So, well, I don't even need to because I can see that this is going to be facing down as well. So I can sit here and say, all right, great. 4A is going to equal to that -1 because that's the only thing in front of this parentheses. So that means my A is going to equal to -1/4. So definitely going to be facing down, okay? Let's draw that nicer, like that, right? So I know it's going to be facing down. Okay, so if that's the case, and my vertex is at 1, 2, okay, so vertex is at 1, 2, I know it's going to be facing down, and I know my A is -1/4. Oh boy. You know what? Let's make this graph 1, 2, -1, -2, 1, 2, -1, -2, okay? So that means that I'm going to go ahead and take and just erase this part and move this to the right place. 1, 2 will be right here, okay? Since A, and I know it's facing down, so the focus has to be below that by -1/4. So I gotta go down 1/4 to find my focus. Let me see, if I go down 1/4, it will be right here, right? That would be my so-called focus. And if I go up 1/4, that would be my directrix. Okay, because those are both A. Then if that's the case, then I can go left and right 1/2, right? Twice the quarter. 1/2, which would be here and here. And this would be my latus rectum. Right? And I can pick those points right out, which is what? Well, actually, it was 1/2, 2 3/4. And then this would be 1 and 1/2, 2 and, oh no, that's 1 3/4. I'm sorry, 1 3/4. Okay. So those are the things that you kind of want to make sure that you can do. All right. And if I'm to draw this, it should look something like this. Let's see here. So close. There we go. Okay, and there it is. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.